Imagine holding a tiny object in your hand. It weighs 0.125 grams, less than the weight of a standard paperclip. But if you were to drop it, that speck would release the destructive energy of thousands of tons of TNT. This is antimatter. In particle physics, every fundamental building block of ordinary matter has an exact mirror image. Electrons have positively charged partners called positrons, and protons have negatively charged antiprotons. Left completely alone in a perfect vacuum, antimatter is perfectly stable. Its fatal flaw comes down to a single, uncompromising rule. It cannot occupy the same physical space as ordinary matter. Because our entire world is constructed out of ordinary matter, the moment antimatter touches anything, a table, a speck of dust, or even a human hand, it triggers an absolute and instantaneous destruction event. To keep that 0.125 grams safe, it has to be completely isolated.
Researchers have to suspend it inside a complex magnetic trap, floating it within a deep vacuum so that it touches absolutely nothing. Now, suppose the power to that laboratory goes out. The magnetic containment field loses power, it fails, and the antimatter slips from its invisible suspension. It doesn't even have time to hit the floor. Long before it reaches the ground, the escaping antimatter collides with the microscopic molecules of air floating freely in the room. That first contact with atmospheric oxygen or nitrogen is the irreversible trigger. The timeline of destruction begins, and the entire event will unfold in less than a millionth of a second. At the exact microsecond those antiprotons touch the ordinary atoms in the air, they immediately annihilate each other. This reaction is governed directly by Einstein's equation, E equals mc squared. Because the speed of light squared is such a massive number, an incredibly tiny mass converts into an enormous reservoir of energy. Chemical fires and nuclear fission leave physical residue like ash behind. In a matter-antimatter collision, 100% of the mass converts into pure energy. Our 0.125 grams of antimatter combines with atmospheric matter, instantly producing a 5.4 kiloton equivalent energy release. Nature leaves absolutely no physical mass behind in this process. It stands as the most violent, perfectly efficient energy conversion the laws of physics allow. At the subatomic level, the initial annihilation produces a chaotic shower of particles called pions, which rapidly decay into a blinding flash of highly penetrating gamma rays. The visible explosion happens a fraction of a millisecond later. The surrounding atmosphere absorbs that intense gamma radiation, superheats instantly, and expands outward into a violent plasma shockwave. There is no unstoppable chain reaction that sets the atmosphere on fire, and the antimatter does not bore a hole through the center of the Earth. The annihilation ceases the exact millisecond the 0.125 grams of antimatter runs out of ordinary matter partners to react with. Despite its extreme violence, the explosion is a strictly localized and finite transfer of energy, limited entirely by the amount of antimatter initially dropped. The strict physical limits of this reaction explain why militaries or rogue groups cannot simply steal or build an antimatter bomb. The barrier is the astronomical energy, cost, and precision required to manufacture and contain even a few solitary atoms of antihydrogen. Look at the sheer size of this blue cylindrical particle accelerator inside CERN's underground tunnel. Even using infrastructure this massive, producing 0.125 grams of antimatter at current technological output would take longer than the age of the universe. Instead of stockpiling it, CERN safely traps these tiny amounts of antimatter to test its physical properties, specifically observing whether it obeys the laws of gravity and falls down exactly the same way ordinary matter does. Humanity creates antimatter to probe the deepest, most precise rules governing the universe, rather than trying to build a weapon. The real value of antimatter lies in an ultimate cosmological puzzle. According to the physics of the Big Bang, the early universe should have created perfectly equal amounts of matter and antimatter. If that perfect symmetry had held, every piece of matter would have found its antimatter twin. They would have annihilated instantly, leaving a universe filled entirely with light and completely void of stars or planets. This animated diagram shows the microscopic anomaly that actually occurred. For roughly every 1 billion antimatter particles that annihilated with 1 billion matter particles, there was exactly one extra particle of ordinary matter left over. That tiny fraction of surviving ordinary matter, the microscopic leftovers of an ancient annihilation, became the building blocks for every galaxy, planet, and living being in existence. Antimatter operates as a perfect absolute explosive, yet its mysterious absence from the modern cosmos is the sole reason we exist to wonder about it at all.